Thursday instead of the Friday. The reason to do that is I was going to put in those like the little fun little experiment type thing in before it, but we might as well test beforehand instead of forget things and then have fun on Friday.
Yeah.
Agreed. So you'll be fine. So we'll do it on Thursday instead.
Maybe Olivia will be here on Thursday.
Maybe I will too.
What about
Yeah. So Friday, what we're going to do is I have some experiments we'll do with like flipping cards and stuff like that. I may not have enough cards, so I know that I found a free app already that if you put your phone down, flip it over, there's a card. Put your phone down, flip it over, there's a different card. So I found one that does that, so we might use that. It's kind of cool. Otherwise, if you have cards, you want to bring them in, that's fine. Yes, sir. Yes, the fun stuff's Friday. When we get back then from the 3-day weekend, we'll start with the matrices, and that'll be basically, you don't need to bring a calculator for like 4 or 5 days. And then, yeah, today we're going to finish out this 12-7. So let me show you why we were working with those Bino CDF things.
Is tomorrow due date?
Yeah. What happens a lot of times when we're working with that binomial distribution, what you were able to do with the binomial distribution stuff, that Bino CDF, it was calculating. So what happens here is that we can actually use binomial distributions to approximate values underneath a normal curve. If your values of n are large enough, this works rather cleanly. Your book does it the old-fashioned, nasty, icky way, by having to calculate a standard deviation and plot out the values and work through a normal curve. We know a short way of doing this. We know that if we use that Bino MCDF of n, p, and our k value, it'll sum a bunch of values between 0 to k. What this does in the grand scheme of things, if that value of n is large enough, I don't remember exactly what the breakpoint is for it, but if it's big enough, and when you're working with your sample, it's going to appear to be a normal distribution. And what the idea of having this normal distribution is that no matter what your values are for your averages and whatever your standard deviation is, those numbers can change all the time. But the numbers underneath the curve itself never changes. 68% is always going to be plus or minus 1 standard deviation. 95% is always going to be plus or minus 2 standard deviations. And 99.7 is always going to be plus or minus 3 standard deviations. That's the idea of norming data, because this will always occur. You guys don't have to worry about how to norm data. It's not a big deal. When you get to a stats class, they do lots of that, because these hold true. Statistics, there are many different ways of norming data. I've heard in the PARC test there was something about a z-score.
Yes.
That's kind of a way of norming data. By using a z-score, there's what are called z-tables that blend themselves into the norm curve. And it's all about these percentages.
I remember that in the part of it, I don't want to.
That's okay. Then the other thing that you guys will eventually do as well, when you get to calculus, there's something called an integration. Integration is finding area under a curve. It's kind of what you're doing here. You're looking at percentages under a curve. This, you're finding area under the curve between the specific values. For example, I'm looking at what is the area under the curve of x squared between the values of 0 and 4. So on my graph, I'm looking at between 0 to 4. I'm looking to find this area under the curve. That's what that means. It's integration.
What purpose does that help?
Area under curve, because eventually you'll look at multiple curve.
Why is a bell curve curving upside down?
It's not a bell. I'm not looking at a bell curve there. I'm looking at the intersection of two separate conics that I can find the area underneath the two
Oh, so
curves.
this is not curves, this is just
No, no.
comments.
Eventually, there are calculus things with this integration that lend into the probability and statistics that will, the numbers we're all working with, everything's landed on a standard deviation. You guys agree?
Yeah.
What happens if it doesn't?
It's a range, paranormal.
Math, exactly. You have to math it. You'll do a bunch of stuff like this. And this isn't even high school stuff. They don't even get to this stuff in high school. But I'm just saying that there are so many different things you're able to do. I mean, you'll do integration in high school, but you won't talk about this via probability in high school. It's more of your math background statistics course as opposed to a business stats course. They probably won't do that, okay? Just so you know, there's so many cool things with stats. I think it's kind of fun. But anyway,
Things with stats.
there are. I mean, like I say, 80% of remember, 80% of stats are made up on the spot, and they're half right.
Do they have any pre-cal courses in college too?
Yeah.
Yeah, because I don't have any math courses for
30%
next
of the
year. I'm
time?
going to be going to
Oh.
so odds are they'll probably just
Do a second. What are you testing into? So here's what happens. We're going to take this idea of using this binomial distribution function to work with a binomial probability. Okay? And a lot of these things work with surveys. When you go through a survey and you're sampling a large group of people, to get a good survey, you want a large sample size.
It's like Family Feud. They survey 100 men.
Correct. Survey says.
Yeah.
And they go ding.
And then Steve Harvey
Or
was the sex joke.
there it is. So if I'm looking at a problem like this, instead of doing what the book does via square roots and finding standard deviations, regressions to the mean, it's a nightmare. We have a button. Okay? We're gonna use a button.
A button?
Well, you might have to press more than one to get there. But, you know, if you pace yourself, you'll be okay. What I want to look at here is what the information they're giving you. They're telling you that there's a survey that has 29% of adults in the U.S. says that someone in their family plays soccer regularly. If you are surveying a random selection of people of 288 adults, what is the probability, 238, excuse me, what is the probability that you will find at most 55 of them play soccer?
That's a terrible number.
It is, but look,
238.
so your end value is terrible. It's 238. What's your p-value? 0.29. And then your k, your expected of what you're looking at here, it says at most 55.
Less than or equal to 52.
It'd be a 5, but yeah, so your k value is less than or equal to 55. So if you think about what's happening here, if you went through the whole rigmarole of norming this data, you'd go through and look at this curve, you'd figure out where 55 lies on it,
That's what I was thinking.
and you're looking at all that data underneath here. Okay, that's what that does. But since this is, what's that?
Does it tell us where the mean is?
No, it doesn't. But in essence, if you went through the whole long gamut of doing this, you could figure all that out.
Oh, okay.
But remember what your Bino CDF did. It took a binomial problem, which we knew as a binomial distribution was this ugly bar chart, which we said was somewhat pseudo-norm looking. And it would calculate all those percentages. So our end value is technically large here. So all we do is press a button. You have Bino NCDF parentheses 238, comma, 0.29, comma, 55. It's a lot of work, I know. Bless you. Remember, where do you find that Bino CDF?
Second distribution, alpha B,
Which means
alpha
second bars.
apps,
Second bars
alpha
Up.
apps.
And you just got to be careful to choose the CDF for this one. Because we're looking at, bless you, we're looking at a bunch of values that get to 55. All right? Now, when I hit the next button, mine's gonna look different than yours, unless, does anybody's show it like this? Okay. A couple of calculators have that because it's the newer version of the operating system. It's not a big deal. If yours does that, great. You just type it in. Trials is your N. Your p-value, you know what that is. And your x value is the same thing as the k. All right? So you put that all in. Now it's going to look exactly like what you guys have. It just puts it in the parentheses for you. So you don't have to waste your time searching for the comma button like I did the other day. And press enter. And there's your probability. It maths it for you.
25%.
Is in the catalog space.
Yeah, you can do it that way. Whichever one's easier for you to remember. It's not a big deal. The normal spot for it is in that second bars. And just go that way. I didn't know where it was when I was showing you guys the shortcut. I had to remember. I'm adding to it tonight. Now, the other thing here is just to remind you guys of when you use this, the regular or the complement.
Those were supposed to probably with K.
Whenever you remember, the Bino CDF will sum it between 0 to your k value. All right? It'll sum it from 0 to k. So if it's sitting where its k is less than or equal to 55, you're okay. It's not a big deal. You would just type in your n, comma, p, comma, whatever that k value is. On the other hand, sometimes it asks for it when its k is greater than a value. That means it's looking for everything after it, up to n. That's when you subtract. Because in this case, it's asking for the values between your k to whatever n is. In order to do that in the calculator, you just work the other way around. What's up, sir? How are you? Practicing you. Don't mistake. Well,
Bye. What was that?
au revoir, Joe Fair. So in this case, it's asking you for the values between the k to n. Remember, everything under the curve has to add up to equal 1. You guys are just dope. So if you find everything going over here, and subtract it from 1, that's when you want to use the complement. The only trick is when you're looking for the opposite side, you have to change the value of k in the calculator. And this is the case when you put it in the Bino, you'd have Bino MCDF. It's still going to be n, p, and then whatever k minus 1. So whenever you're looking at one where your k value is going to be greater, you have to do k minus 1 in the calculator. So I would type in 54, and then I would find the complement. Because that's everything left over.
So after you do all of that, then you do. So after you do all of that, then you do 1 minus whatever that was.
Yeah, because in your calculator, whatever you get in your calculator, like this example here, let's say that's what it was. I'd hit 1 minus my answer, and that'd give you my answer. Okay? I would do that. It's not the right setup, but I would just do that. Instead of trying to do 1 minus the whole Bino CDF thing, I would probably screw that up.
Yeah.
So if I just do the Bino CDF, get the answer, do 1 minus, because it was stored in there, it's just a little bit cleaner. What are you guys asking? Good deal. Yes, sir.
The minus 1, that's basically because it's greater than or equal to it, so everything less than 55.
Correct. Yep. That's exactly why we look at it that way. All right. It's a very, very simple way of doing it without having to worry about doing that whole crummy thing that you do in the calculator. Yes, ma'am.
So do you use the k minus 1 and then 1 minus the answer, or do you just do?
Because, just like Zach was saying, is that when you do k minus 1, since you're looking at everything greater than or equal to 55, I'm looking to start here and go this way, which means I'm going to start here and go that way. Take that chunk, subtract it from 1, and that gives me everything that's left over. Just using complement rule. Okay? We'll try one?
Yeah.
All right. You'll notice real fast, what was the percentage we got on ours? It was like 0.248 or something like that?
Yeah.
The book, when they rounded their stuff through, they got 0.025. You're gonna be within a couple hundredths, couple thousandths, depending upon the rounding. It's close enough. For our purposes, for what we're looking at here, they're talking about a binomial distribution that is pseudo-normed because n is large. So it's norm-ish. So try this. Try these three real fast. Take your time. Be careful when it gets down to the third one there. What I've been telling students throughout the day today is when they get to that third one, to figure out what the values they're looking at, draw a number line. And that usually sparks the idea of what it should work out to be. Okay?
So is it 0.02 for people?
When you start this out, the first two,
Eye.
look what happens if you get hit in the eye. Okay?
You're a bully, Thomas.
Yeah, just like my 6-year-old.
Thomas is just like his other child. Was I wrong?
In this case here, we're looking at our k value is going to be less than or equal to 15. We know that our n is 460, the p value is 0.02, and this first one, k, is less than or equal to 15. Will that work with just straight binomial CDFs? And the reason that that works is because in the idea here is between 0 to 460 is my full set of data. I'm looking at what happens between 0 to 15. The binomial CDF will add up all those data points for me. So I just type in the calculator. Binomial MCDF 460, comma, 0.02, comma, 15. It gives me an answer. Whatever your answer is close enough to what the book was saying. We're within hundredths here. Okay? When I do it the next time it's asking for probably the 12 or more. So now I'm looking at going from 12 to here. The binomial CDF isn't going to give me that. It'll give me from 0 to, what I want to do it from 0 to 11. I'm going to go to 11 because everything that's left over is 12 to 460. All right? All right. So this is the point when you have to do your binomial CDF. 460 doesn't change. 0.02 doesn't change. But I have to do k minus 1. My k value in this case was 12. And since I'm going greater, it's going to be 11.
Oh, it's 1 minus, right?
So I get that value, and then I hit 1 minus whatever that was. And that, bless you. And then I'll give me that's going to give me everything from 12 to 460, probability being in that range. It should be a larger value. Or whatever.
I just did 1 minus that. Is that what I'm looking for?
Yeah, that's how you're doing. And now the last one.
You take the minus 18 and then subtract the
I guess, can I take a guess?
Because look what happens. This is why I say draw the number line here, just so you get the visual of what it is.
Take a guess.
1 second. You're looking at what happens between 6 and 18. To get the values of 6 and 18, think about what the calculator can do. The calculator can get all the values between 0 to 18, and then can get all the values between 0 to 6. Where's the overlap? The 0 to 6 chunk. So all you have to do is get the CDF of the 460, comma, 0.02, comma, 18. That'll get you everything from here to here. And then just subtract out here to here. And that is 460, comma, 0.02, comma, 6. You're taking out the overlap just by subtracting it out, because that Bino CDF will sum it from 0 to whatever K is. Yes, ma'am?
Wouldn't you take out, for the, would you subtract like 460 for no 2 and then $1? Because 6 is within the range, 6 to 18.
Let's go.
Yeah, it would be greater than or like between 6 and 18, so it includes 18 and it includes 6.
Is it greater than 18?
No.
So I'm including 18.
So it's not, it's not having 6 and 18, right? You don't have to worry about the.
I never even thought of that. I never even thought of it, because this, I was just doing it like this, because that's just giving you the values, because it'll cut it at, it'll include 18, by backing that out, it doesn't include the 6. So this is technically between 7 and 18.
Yeah.
So you're right, it should be at 5 to include the 6. That's right, yeah, no, guys, she's right. She's right. She's right. Because if you think about, well, look, guys,
I'm just me.
I'm not gonna lie, I didn't think of it that way. That makes total sense. Because in a number line, and here I am saying, well, use a number line, you want to be between, including 6 to 18. Well, if I subtract out at 6, I'm looking then from 7 to 18. So you got to subtract out at 5 to include the 6.
But you include 18. So
But I'm including 18. So how about this? If I throw something like this on a test, I will say including 18 and including 6.
So does that mean? Or you can just not put it on the test.
Agreed.
do you think you would give us a problem like this and then not put it on the test?
That is a good question.
I feel like you can.
Stop giving him ideas.
Oh. To be honest with you, if you know these three, you just fill them in. Because all you're doing is subtracting and cutting it in half. This is really all you have to know. Yeah. If I'm going to include them, include 18, I wouldn't change the first one, because 18 would be included. And then if I'm going to include 6, I'd have to subtract it from 5.
So you can say excluding 18 and 6.
Yeah. And if it was purely between, then I would do 17 and 7.
Yeah, because between is included.
Correct. Does that make sense? I never even thought of the semantics of it.
Yeah.
We failed English.
That's a really big word that I don't understand. Me too.
That's a good question. Let's do these then. Let's start at 41 through 55. Same page. Yeah. We'll do 41 through 55, same page, 12-7. Tomorrow we'll do a bum rush through all the sections, make sure you hit the points of what we need to remember, things like that. We'll be done with all of it and tested Thursday, so it should be good to go.
How many questions did we test?
Not a clue, I'm not done with it yet. What are you saying, Olivia?
I actually don't know, and I'm just.
Yes. Memorial Days are early this year.
And then we have